So here in this question it is asked as we have given an array and we have given a target value, and we have to return the what is the minimal length of the this subarray possible in which whose sum is greater than equal to target. And in this case, and in the case when we don't have to find any kind of subarrays, we have to simply return the zero value. So like checking for this test case, there's a 2 3 1 2 4 3. We have to find the subarrays. First of all, we have to find all of the subarrays, then we have to return the how many of the minimal length of subarray. So let's say we see thing 2 3 5 6. So there's a okay. So yeah, so what we have to see there, the subarray of this 1 2 4, so it is of length 7. Okay, so we like we have to seek for the whose sum is greater than or equal to 7. Okay, so uh, okay, so basically like we when we starting from this, so up to here this subarray is it also its sum is also greater than equal to 7, then this obviously. But now try to find the that subarray who has minimal length. Now if we starting from here, so it is 4 then 6 then so this subarray also, this subarray also. Now if we starting from here, so like this subarray it has also minimum, but it is of 3. Let's try to find whether we can find any of which is less than 3. Okay, so now if we start from here, so it is of again length 3. Now if we start from the length if we start from the element 4 and the 3, so this is the minimum length which is of 2 length. So this is the minimum length possible here, which is a sum greater than equal to target. So obviously its sum is equal to target, so this is our required answer, so that's why answer should be 2. Similarly in this case, we have to see for the target value 4. So if I'm talking about this subarray, or I can say if I'm talking about this subarray which consists only this element, so what are the minimum length possible here? 1. Okay, now if we are going to check for target 11, but we see one thing there, like when we take the total count of if including all of the elements, so what is total count is 8. So if even we take all of the if we take whole array as a subarray, but still its sum is less than target, so we can it is not not possible to find any kind of subarray whose sum is greater than equal to 11. So in these cases we have to return simply 11, return simply 0. Okay, so the brute force that comes, first of all, what is the brute force? So simply the brute force is to generate all of the subarrays and check the subarrays who have length who have sum is greater than equal to 7. So we simply take a count vector and simply update each of count, whether if we have to find any count which is less than a previous count, so we update value and return the minimal count here. But there's an issue there. On generating all of the subarrays, it takes off n square. Now during generating subarrays, we have to also check the sum into this subarray, so that takes of n in the first condition. So basically it takes about of n cube, but due to constraint of 10 power 5, it gives TLE, so we should go for the most optimal approach here. So we see one thing here, like first of all it is given in the question that all of the elements are positive, so it is guaranteed like when we starting of any subarray, when we start to move to the right, so we see one thing like sum is since all of the elements are positive, so it is guaranteed that sum is increasing in the right side. And if we do so we can say let's talk let it seem as a window. Okay, so if we expand this window along the right side, so its sum is increasing. Similarly, if we shrink this window from the left, so its sum is decreasing. Like let's say if I'm talking about this window, so its sum is let's say s, and if we expand it to the right side, so its sum is greater than that previous value x. Similarly, if we shrink it from the left side, so let this become, so its sum is like decreasing. And similarly if we long shrink, the its sum is also decreasing. So we should try, we have to find those subarrays whose sum is under this limit. What is the limit? The target. So basically, avoiding this brute force, we simply see this is like a sliding window question. So we have to find all of the subarrays. So so what we do here, basically in the traditional sliding window question, we initialize our I pointer here and j pointer here, basically 2 pointer here. Okay, and we up to where this loop is goes on. So this j loops goes on until it exceeds the size of this subarray, size of this array. Okay, and we expand it and when it is under the condition, like when its sum is greater than equal to target, so we try to shrink it until until it falls in the category. If it fails this category, so we expand it. Okay, so simply a typical a simple sliding window question. So first of all, initialize I 0, j is a 0, and what is our answer? Let's say I denote our answer as what is the minimum length possible. So we have to seek for the minimum, so that's why I initialize it with. And also, okay, so here is our sum vector, because I have to count, so that's why I have to judge whether it is under the condition or not. Okay, so I made a I run this loop from here. Okay, so sum plus equal to v of j, and now check it. Now we see it, if this sum is greater than equal to target, what it means. If first of all, I have to also put target here. Cn of target. Okay, initialize and then target, then initialize vector. Okay, so up to when, if sum is equal to, while sum is greater than equal to 2, so we simply shrink our window, because we have to trying the what is the minimalist or what is the minimum length possible. So in this case, first of all, in update our answer according to this is min of answer comma j minus I plus 1, and during shrinking, first of all, subtract the leftmost part, so sum minus equal to this v of I, and then update our I pointer. Okay, so this is the condition. And when, and since after, and since during one operation I expand my sliding window, that was j plus plus. Okay, so now finally we see if our now if I'm talking about, if we false any kind of test case like 3, whenever there is there's a no subarray possible who is a, so in this case, what it means if I do not able to find any kind of subarray, means our answer vector, our answer variable, it doesn't update, means it is remaining the int max. So in case this so okay, so in this case we have to return simply 0, and else condition we have to simply return that's a ans and then and return 0. Okay, so let's say we have to go for this test case 2 3 1 2 4 3 now. So this is of length 6, and what is the target value here? So this is a 7, and what is the array here? 2, then 3, then 1, then 2, then 4, then 3. Okay, so it should give the value as 2. Okay, let's check for the other this test case also, whether is it wrong or so this is of length 3 3 6 8, so 8, and what is the target value here? It is of 11 length, and we erase it. So 1 2 3 4 5 6 7 8. Okay, so now we can erase it, and now check it whether because we are not able to find any kind of subarray, so it should return 0. Okay, so this is correct. And we simply see what is the time complexity here is. It is of time complexity is of n, because j loops here running here. And what is the space complexity here? So simply it is of 1, because we don't use any kind of data structure extra space here. Okay, so that is the question.